So, guys, hello and welcome to the chapter of light, propagation, illumination, pinhole camera, and magnification. This video covers a quick revision and questions on the UTME and the Waec 2022 examination prep. I do say if you find anything interesting after watching the video, you can click on the subscribe button, and if you have any questions, query, or suggestions, you can kindly send a message to me via the email, or you can as well drop the comment in the section box. So I'll start with the topic, and we are going to start with the first question. About the first question, we have shadows and eclipse result from dash options: refraction of light, rectilinear propagation of light, diffraction of light, and reflection of light. I think this should be diffraction and not detraction. So now, about the topic about propagation, the first thing you might have studied, apologies, I think this stuff is loading, is the concept of what you call the rectilinear propagation of light. That is the aspect of light that tells you about the movement of light traveling on a straight line. Now, and about the rectilinear propagation of light, we talk about three other applications. Light travel in a straight line, which I believe you have performed the simple experiment with cardboard in your junior classes. So some of the applications are formation of shadows, which are applications. Apologies about the handwritings. Formation of eclipse. And the third application is the pinhole camera. So which I think is more like what the academic team are going to focus on their question on this chapter. So the introductory chapter to light is just the propagation, the illumination, the pinhole camera, and the magnification of the pinhole camera and nature of images. So we move to the next one. This is a direct question. Light travel through a straight line. The process at which it travels through a straight line is called linear propagation of light. Another law you can also keep in mind is law of reversibility of light. That is, light rays can be reversed. If light is actually incident at one point, it can also pass through that point back to the point of incident. So that is that for now. I won't talk too much of concept. Just keeping in mind, you have to have a notebook and a jotter to jot all important points because they are very, very important. For other types of related questions. The next question. An object is 20 centimeter. An object of height, 20 centimeter. Now, we need to just focus on the SI unit because it's quite important. I hope this is also in centimeter. That is why I'm not going to convert. So always watch out for that in physics when you are doing physics calculations and numericals. Object of height 20 centimeter. I'm going to write that as the object height. I'll just write it as object height, and that is 20 centimeter. Is located at a distance 50 centimeter from the pinhole. You can see application of rectilinear propagation of light. The pinhole camera we just discussed about. Now, at a distance of 50 centimeter from a pinhole. So the object distance is, we denote object distance by U as a 50 centimeter. I hope students have studied about the two application and formation of a pinhole camera. You know, a pinhole means a very, very tiny hole that is not that big. So that is why we call it a pinhole. If you need to know more about pinhole, I have concept video, but I think this checklist video can actually tell you all what you need to know. As you increase the size of the pinhole camera, the image form, which is always real and inverted image. I think is another good point. The nature of image form in a pinhole camera is real and inverted. The bigger the hole, the blurrer the image. Because I'm not quite sure if the academic team are going to give us question on all those stuff. But sometimes we see question like that. We can also continue with the question. We have an object of height, this, located at a distance. The object's distance is denoted by U. For now, you're only limiting your questions with respect to pinhole. When you get to the reflection of light, we're going to talk about mirrors. And refraction of light, we talk about prisms. So stay with us for the best of physics videos and explanation. Now, the question says, if the distance of the pinhole from the screen, if the distance of the pinhole from the screen is 25 centimeter, the height of the image is that height of the image is what we are looking for. Let me call it X. Now, if the distance of the pinhole, from the screen, what is formed on the screen is the image. So in physics, we use V to represent image distance. We'll take that as 25 centimeter. So I think this is on the concept of magnification of image formed in the pinhole camera. Generally, the magnification is telling you how big and how large an object is. And to do that, we relate the magnification of an object can be the image height. It is always dimensionless. It has no SI unit, dimensionless quantity. So image height over object height. It is also given as magnification is image distance over object distance. I hope you have studied this in your junior classes. And if you have not studied it, it is very simple to know. It's just like it's a very, very small hole that is projected across what? You can just say a light ray was incident. I think this is too thick. I just want to do a quick illustration, a very quick illustration, very, very quick one. So now, if this is the light, then it was incident. Then you can just say, and it was passed through a pinhole. Look at it. Let me just use, let me use this. The black is still okay. See, the ray of light is coming like that. Wherever the ray of light are meeting is called the point of where the image is from. Look at it. It's meeting here. So I can extend the line or ease of access like I do say, and then meet there then. And let me come here also. I hope I can still form a straight stuff. So it should be a straight line anyway. So that is that. Then let's say this is where the cardboard is placed. Wow, this hand is not straight. I was trying to form something for you to see what we're talking about for understanding's sake. So, or let me use my hand to draw better. I think my hand will be the best thing in this kind of situation. Let me just extend and bring something like this. So what I'm trying to tell you is that this is the pinhole. The image are intersecting at the transdance. The image is always formed on the screen. These are simple stuff I hope you have learned before in your junior classes. So we have the height of image height, object height. We have the image height. We have the image distance. We have the object distance, as you can see. So we relate the formula like this, just a quick illustration. So we can now set a kind of magnification is image height over object height. Magnification is also image distance divided by object distance. So by symmetry, we can say, sorry, I'm showing here, image height over object height is equals to image distance over object distance. So my point is just to substitute all these values. You're looking for image height, we call that X. The object height is 20. The object distance is 25, and the image distance rather is 25, and this is 20. So without wasting time, if I don't make mistake, this should be, that is 400 over 25. That's what I'm saying. I hope the team don't make mistake in what they have done here, because all what is here, none of the option is correct. This 20 get cancelled out, and X here is equals to 25. No, it was 50. I'm actually the one, U is 50, not 20. I'm actually the one that is not substituting the right stuff. So the team actually know what they are doing. I'm actually the one. This is 50. So my way, this will not cancel this now. So I can only cancel 0, get cancelled out. I told you if you are not used to this method, but if you follow my series by now, you should have understand the way I always go about all this stuff. So now here we can just say 25 times 2 is 50. 50 divided by 10, divided by 5 is 10 centimeters, which is the right answer. For you, if you don't get it, I always say this, just cross multiply 25 times 20 divided by 50. It's going to make this answer valid, and that is the correct answer for that question. So let's move to the next one. This is just an introductory part to light. So I don't think it is going to be too difficult for us to understand. The third question, which of the following phenomena is not a direct consequence of rectilinear propagation of light? That is, the ability of light to travel in a straight line. We've talked about the consequences. Lunar and solar eclipse. Lunar eclipse is eclipse of the moon. Any type of eclipse, although basically there are three types. Lunar eclipse, which we call eclipse of the sun, eclipse of the moon, solar eclipse, which we call eclipse of the sun, and the one we call annular eclipse. Please keep that at the back of your mind. It's important. Image of an object in pinhole camera is also very correct. Diffraction of light is not a consequence. That is the answer. Shadows of opaque objects is a consequence. I've talked about the propagation of light and how it is being formed. So I talked about formation of shadows, formation of eclipse, and the pinhole camera. So this is eclipse, this is shadow, this is pinhole camera. So the one that is not there here is what diffraction of light, which we are still going to talk about in the later part of our checklist. So that is the answer, because this diffraction of light is not a consequence of rectilinear propagation. And that says, if the size of a pinhole camera is increased, as you increase the size, the image form become dash. That is a very, very good question. I talked about it not quite long. As the size of a pinhole camera becomes larger, the image becomes what? Brighter and becomes blurred. I think I talked about that in the previous slide. You can see image from the pinhole camera is real and inverted. And as the size increases, image becomes blurred. I was thinking the team will not be able to pick out question. And again, talking about brightness, let me also let you also know our brightness. I think it is important for new pattern of question is inversely proportional to sharpness in the pinhole camera. And that is why as you increase the size, the image become brighter and the sharpness reduces, which makes it become lower. So choice A is very correct. This is the answer. You don't need to waste your time to understand this because it's like a direct question. And as you can see, the introductory part of light is kind of very simple. And all is because we are actually following the right procedures to explain them in such a way that we are not going to have any issues. So the next question about this, we have which of the following is not self-luminous? Very good. Under the propagation of light, we classify objects to luminous objects and non-luminous objects. Self-luminous are just those that produce their own light. Please keep that at the back of your mind. A very good example are the incandescent. You can see the word incandescent means they produce light as a result of heat. So they work on heating effect of current. When we get to magnetism, I'm going to talk more about how there is an incandescent electric bulb and the fluorescent tube. Don't worry, we are going to get to the chapter. But incandescent lamp can produce their own light. They produce more heat than light. The same thing to the fluorescent, incandescent fluorescent tube. So they are self-luminous. They can produce their own light by heating effect. I hope you are getting heating. Now, lighted candle, as the name stands, lighted candle, you have to light it because before they can produce their own light. So they are not self-luminous. The moon is self-luminous. Though moon is also classified as an opaque object. Please always keep that in mind. I hope you have studied this in your basic science in junior classes. They do not allow the passage of what? Electricity. We have classified objects also in terms of the carrier of light, that is translucent, transparent, and opaque, which I hope you have studied in your junior classes. And if not, transparent allow passage of light, translucent and a little amount of light. So keep that at the back of your mind, whereby opaque objects do not allow light. A very good example is the more. So the self-luminous, the one that is not self-luminous yet, is nothing but lighted candle, and that is the answer. Please be careful not to give examiner marks. So you need to understand the concept very well. On to the next question. The next question, I think question 6. If the distance from a, that's tautology, I think we should clean one. If the distance from a light source to a screen is doubled, the illumination on the screen will be the dash. Very good one from the Mosaic Academy team, because we are talking about illumination of light. Now, to understand this type of question, because I think this is a new pattern of question, illumination of light, that is when light is traveling. I said light rays can be reversed. They can go back and forth, back and forth, back and forth. And light ray travels on a straight line. Newton experiment. We have a lot of scientists. It is not only Newton. You also have another experiment we call YDSE, Young Double Slit Experiment. But for UTME student and Waec student, you don't need it. For my A-level students, available on my channel, full concept video of YDSE experiment, Huygens experiment, and so on and so on. Diffraction pattern of light, Doppler effect of light, and interference of light. All these are available for A-level students to watch, for them to also have full idea of what is needed. And maybe when your exam is very close to, I'm talking to the A-level students now, I'm going to do something like this for you guys, which we are going to take a series of A-level questions with respect to your syllabus as well, from the beginning to the end. So back to what we are doing. We are talking about illumination of light. Now, let it be known that illumination of light is said to be inversely proportional to the square of distance. Illumination of light also obeys what we call the inverse square rule. Inverse square law. I'm just writing this for those that are seeing this for the first time. Concept video available. I have all concept video for all topics in physics. I'm only trying to upload them one after the other. Please note that. Sorry about those people booking. I think I am supposed to off all those stuff. Now, illumination of light is inversely proportional to the square of distance. So look at the question. If the distance of the light source on the screen is doubled, initially the distance was d, and it was now doubled. What will happen to the illumination? I just don't need to do that. I can say illumination will now be equals to 1 over, it has been doubled to be 2d squared. So it will be 1 over 2 squared, 4d squared. So initially it was 1 over d squared. Now it is now 1 over 4d squared. So what happened to the illumination of light on the screen? It is what? 1/4. That's 1 over 4 bigger than the initial one. The initial one is 1 over d squared. When it was doubled, it's 1 over 4d squared. So it is 1/4 greater than what? The other one. So the answer to this is not the same. It is not twice as much. In fact, it is not halved, but it is 1/4 as much. So this is the answer to that. Keep this type of questions. Keep this formula at the back of your mind about illumination of light, which also obeys the inverse square. The next question for today is going to be in the next slide. Fine. This is the question number 7, I guess. An annular eclipse occurs when the dash. Now, about solar, lunar, and annular eclipse, which are the type of eclipse we talk about. We are just talking about when a light is traveling on a straight line. It is being blocked by an obstacle. The types of what? The image that will be formed is now called a shadow if it is on ground. If it is in the celestial bodies, when I say celestial, I mean heavenly bodies. When obstacle blocks what? Light traveling on light that is traveling on a straight line, it's going to give you what is called eclipse. So eclipse can also be total eclipse and they can be partial eclipse. I hope you have studied that also in your junior classes. And if you have not, I am only giving you a quick note on that. Total eclipse is called umbra. I hope you have heard about that. And if not, there's always a first time to everything in life. And there's another called partial eclipse when it is not full. It is called penumbra. Penumbra, for the sake of other questions, especially Waec student, those are simple stuff, you know. So we now form the 3 types of eclipse. We talk about solar eclipse, we talk about lunar eclipse, In your junior classes, solar eclipse is also called eclipse of the sun. Lunar eclipse is called eclipse of the moon. And the special type of eclipse we call annular eclipse. This is very simple as well. You have talked about the position of the earth and the position of the what? Of the moon. Moon is between the what? The sun and the earth. So that is that. Then earth is between the sun and the moon. That is this. Annular eclipse is a special type of eclipse that is formed beyond the umbra vertis cone. I will just use that. I said they are formed, let me write, beyond the umbra vertis cone. Vertis cone. Now, one thing we need to know is that when we are drawing the diagram, maybe I should do that in a few minutes. Maybe. I hope this will come up very quickly. Just hope it's still loading. So my point is, maybe that is why what I'm trying to say is that normally, if you try to intersect the extreme ray of light that is coming from the sun, instead of them to meet at the earth, they are meeting before. I hope this is back. Okay. I want to do the stuff for you. I want you guys to see it. So I'm going to draw my first circle. Please come. It's coming in red, no problem. So I draw the sun and I'm trying to draw the earth. Like I said, this is a quick concept that will quickly give you what you need to know. This is the sun and this is the earth. My earth is supposed to be bigger anyway, but diagram not drawn to scale. So now, from what we just talked about, normally the ray of light are formed by actual what? Intersection. Where the ray intersects is the point we call the point of image. I'm trying to bring something that is let me use a blue and let me bring this now. So if the ray of light is coming from here, let's suppose the normal intersecting ray, and is reaching this place, and the other one is coming from here and is reaching here. Now look at the extreme ray of light. Should I use a broken line or I use a line with arrow? Let me change the color for visualization. Yeah, let's use a brown. So now look at this particular ray of light, which we call extreme ray of light. The extreme ray of light are now intersecting before the earth. This is what we call extreme. For those of you who don't know, it is always above this. Wow. I will not use this type, but I don't want them. Let me use the normal type of rays, which I believe is the best for now. So look at this now. Then I'm going to take it like this for you to see. That's why I'm trying to use a brown. Then the second one, which is extreme ray of light, that is supposed to form a total eclipse, are now intersecting. They are now intersecting beyond the extreme lines. Look at the point I want to draw this thing so that they will intersect beyond that point. Now they are now going to intersect. I'm drawing this one. I want them to intersect at that point. Good. Now let me use a red. Okay, I think I have a red. Maybe black will do it. Look at here, guys. This is the point where they are intersecting. So the image that is on here, I will shade here. Beyond the Umbra vertex is now called annular eclipse. So this is what they call annular eclipse. Some of us that we were born, I think the last one occurs 2002, if I quote it right. Now there will be a kind of let me say total eclipse, whereby the whole earth we are going to see something like a kind of a dark situation, a dark total eclipse that will be formed just for a few seconds, because it is not what happens frequently. It happens as a result of rotation of the light. Geographer will tell you more about this. But what I just want you to keep in mind is that they don't meet at the point of umbra. They meet before beyond the vertex of the umbra. When you draw the extreme lines, they intersect beyond the vertex of the umbra cone. So any type of eclipse that behave like that is called annular eclipse. And at that point, you are going to see kind of total darkness for a few seconds. I know some of you that were born 2002 and before 2002, you understand what I'm talking about. Those of you in my country, generally you understand that you've seen it before. Some of you have watched it in films. whereby you talk about a kind of what? This is where total eclipse is supposed to be formed. So at this point here, where these things are intersecting, you can see, we say this particular point here, let me call it M, this is the earth before, beyond the what? Intersect, before, beyond the earth, they form a kind of intersection with the extreme lines. So extreme lines are just the lines that is required to form total eclipse. So when the Vatesian line is beyond the umbra cone, it is called what? An annular eclipse. So now from here, look at this. In fact, if you don't have idea, you can just read through the options and get your answers. Earth is between the sun and the moon. You know the type of that is lunar eclipse. Moon is between the sun and the earth, solar eclipse. The sun is between it's not possible. Extreme ray of light from the sun cassette after reaching the earth. We can see. And so this is the earth now. Beyond the earth, they are intersecting. This is what I'm explaining. I think it goes with the options of the examiner. So that is that about that. And that's the answer. The next question is which of the following has the highest frequencies? I think this is on electromagnetic radiation, which is example of light. Very good for the team that sets the question. Now, which of the following has the highest frequency? Now, we should understand that electromagnetic radiation, we've talked that under the concept of wave, are classified under, they are given by a shortcut we talk about gasoline. So, which I was able to tell you under the concept, and if you are saying this for the first time, it is not a big deal, you can still learn. Gamma ray, X-ray, visible light, ultraviolet, visible light, infrared, and radio wave. So this is arranged in the term of what? Increasing frequency and decreasing wavelength. So for those of you that are seeing this for the first time, so gamma ray, X-ray, ultraviolet, visible light, ROI-B, dispersion of light is a topic we are going to focus on as well. Infrared and what? Radio. So this is just which of them has the highest frequency amongst this list. So you need to be careful with this type of question. Some question will not put this. So they want you to know all examples of electromagnetic radiations or electromagnetic waves, the way you call it in the junior class. So between all these, thank God, the one that has the highest, which is radio wave, is also here. So we can put radio wave as the question answer. So I hope you understand that. Then we'll go to the question 9 and the question 10 of today. So about the question 9 and question 10 of today, we can quickly solve. We are told in the question that an object is 2.0 meter high. Look at the options and in centimeter. So I'll convert object height. I think it's on magnification concept. This is 200 centimeter. That's 100 centimeter make 1 meter. So I convert 2 meter to centimeter. At a distance of 5 meter, I also convert 5 meter to centimeter. So you just need to understand that as the distance as object distance. So please note that object distance is always u. We've talked about that the other time. I'll convert that to 500 centimeter. Why am I doing that? Because the options are in centimeter. Conversion is also important. What now happen in front of us from a pinhole? If the image height, image height is 4 centimeter, this is already in centimeter. What is the distance of the frame from the pinhole? The distance of this frame from the pinhole, that is the image. The image is formed on the frame. Image distance is x now. So situation is similar. Formula also must be similar. So formula wise, we say image height over object height is equals to image distance over object distance. So by simplification, we have image height is given as, we have to just image height is given as 4. Object height is 200. And following this, image distance V is what we are looking for. Object distance is 500. For my way, I say these 2 0 gets cancelled. You guys are used to me. You can say 2 year 1, 2 year 2, 2. So on simplification, 2 year 1. And I told you if you don't know how to plot, you can just cross multiply. So from here, S is also equals to 10. As 5 times 2 is 10 centimeters. So I think the 2 questions that was set by them is also giving us 10 answer. So that's that. Here's the question, last but one. Then we move to the last question. The last question is Let's read through the last question because I think it's a very simple question. Radio carrier waves are generated by causing electrons to rapidly oscillate in dash. Electromagnetic radiation, I talked about it. Gazuli, it's good for you to keep in mind. Let me quickly tell you how each of them is formed, if that is just a quick concept, or let me quickly map them out quickly. Gamma ray, you guys know gamma ray are formed in the nucleus of a radioactive substance. Chemistry student, alpha, beta, and gamma. So gamma ray is very simple to know how it is formed. It is formed in the what? Nucleus of a radioactive substance. So they are formed as a result of nuclear change in atoms, nuclear energy, nuclear. We are still going to do concept video on that, questions on that too. Nuclear changes in a radioactive substance. We move to the next one, X-rays. Now, X-rays are generated due to collisions. Let me help you write because you need it for some questions also that we test you on how they are being formed. I have a video on that, under it, where we talk about electromagnetic radiation. If I will take it to the highest of the highest level, we talk about Wien's black body radiation. We also talk about Joseph Stefan's and other things you need to know. Don't worry if you are just Waec or Neco student or Jamb student, you only focus on this because all what is going to be done here is going to be within the scope of the syllabus. Now, X-ray. Now, about X-ray, like I said they are formed due to collision of electrons with heavy atoms. I hope you have learned about X-ray in your chemistry, collisions of electrons with heavy atoms. Heavy atoms. In fact, it was discovered by Röntgen. But about discovery now, don't let me waste time. I have a lot of things to talk about. Yeah, ultraviolet. Ultraviolet rays are generated due to high energy. Please keep this in mind because a lot of questions, high energy or high sensation, the way you will see it in your Jamb past question, traditional way. High energy, they are generated by high energy changes. And there's inside the nucleus of an atom, none. That's where you see them. High energy changes. Please always keep it in mind in what? In an atom. Energy changes of an electron, energy change of an electron in an atom. Anyhow, visible light, that is Roy B. They are formed from, we said, different speeds. Let me just write. Visible light are formed due to different speed, different speed in glass, or say different refractive indexes, which we call N. We're still going to talk about that, don't worry, in glass, refractive index. So they are formed due to different speed of what? Of colors in glass. That's how visible light are being formed. Please always keep that back of your mind. It's so simple to know. When we get to chapters of dispersion of light, you understand more about what I'm writing. And then infrared. About infrared ray, just for understanding, infrared are forms as a result of low energy changes in the nucleus. So infrared are due to low energy. Just want to give you important fact. The energy changes in electron, or in an atom. Anyhow, because inside you have electron in atom, even though they are placed outside the shell. The last is radio wave, which is what the question asks. Now, radio waves, which is the last one, they are generated. Let me just say radio wave here. Radio waves are generated. They are generated due to rapid oscillations. You can see rapid oscillations of electrons in the transmitter. Rapid oscillation of electron in transmitter. In fact, if you don't know these stories, you know that you have been to a radio station before. And if you have not been to a radio station before, it's still not a big deal. Radios are what? They generate frequency, they transmit frequency by oscillation of electron inside of transmitter. So the answer to this, radio carrier wave are generated by causing electrons to rapidly oscillate from where? not in microphone. Radio waves are not generated in microphone, not in a quasar cables, but in a what? In a transmitter. Transmitters, electron move rapidly and randomly and oscillate between their main position, and because of that, they are transmitted to various tasks. So guys, this is where I'm going to stop on this section. I have, like I told you, we quickly map out the checklist of propagation of light, illumination of light, KO camera, and magnification of light. So I hope you have learned one or two things under this chapter. The next chapter, which is chapter 25 of your syllabus, we are going to 39, I told you, is reflection of light. So see you guys soon. If you find anything interesting, kindly subscribe to the channel and share the content with friends. Bye.